right, on page 516, 114, this black expression is the limit we're asked to do. As x approaches 0, this is approaching the indeterminate form of 0 times the natural log of 0. And as x approaches 0 from the right, natural log is approaching negative infinity. So this is an indeterminate form, but it is not an indeterminate form on which we can use L'Hopital's rule. But we can always take any factor and put it in the denominator if we make it into its reciprocal. In other words, if x is in the numerator, we can put it down here as 1 over x, the reciprocal, because 1 divided by 1 over x is the same as 1 multiplied by x over 1, which is x. So we can take this x and put it in the denominator as 1 over x. Now our limit is of a form, an indeterminate form, on which we can use L'Hopital's rule. So we'll take the derivative of the numerator separately and the derivative of the denominator separately and take the limit still as x approaches 0. But here you want to perform some algebra to simplify the top fraction divided by the bottom, or the top fraction multiplied by the reciprocal of the bottom. And that simplifies to just positive x. So this is the limit as x approaches 0 of just x, and that's how we get this one.